Now, let's try to solve this problem. A car starts from rest and accelerates uniformly. After 10 seconds, its displacement is 25 meter. Calculate. Okay, so when you reach the end of the problem statement, don't straight away rush into the question. Okay, many students would probably just straight away label this is T, label this is S, then straight away jump into the question, ask for V, then you find the equation to sub in. The idea is no, okay? You should have a clear understanding of the problem first before you even start to move on to the question. Understand the situation clearly by visualizing it using a diagram. Then only you start to look at what is the question asking for. Okay, always understand the problem before moving on to solve the problem. Okay, so in this case, you have a car, then it starts from rest, then it accelerates uniformly. So what I do is I will use a dot to represent my car. It's fine. You want to use a dot, you want to use a cross, whatever. Okay, so it starts from rest. So I believe initially it's 0 meter per second. And after that, it mentions that it will also accelerate uniformly. So I'll draw an arrow here and label it with an A to represent that it will be accelerating uniformly. Okay, then after 10 seconds, its displacement is 25 meter. So assume during the course of that 25 seconds, you move in a certain direction. It doesn't tell you a specific direction, so just simply get direction. So at the end of the 10th second, you travel a distance, or you'll be 25 meter away from the initial position, and the time pass is 10 seconds. Okay, so this is the first step. You visualize it. So let me label it as first step. Okay, visualize. And this should happen before you even rush towards the questions. Okay, so if you notice here what I label here, I didn't really label this is U, or this is, I didn't label this is U, or I didn't label this is S, or I didn't label this is T. Because what is U, what is S, what is T, all these kinematic quantities S, U, V, A, T, right? It change depending on which question you are doing. Let's say the SUVAT in question A can be different from the SUVAT in question B, can be different from the SUVAT in question C. You cannot determine straight away what is S, what is U, what is V, what is A, what is T just by reading the first sentence. Therefore, I label the value here because this value here it's for me to understand the situation. It's not for me to substitute and get answer. Okay, so that's the first step, that's visualize. The second step, which we will move on to the second step, which is to determine the initial and final position. So initial and final position will be different for every sub-question. Each sub-question has its own initial and final position. So now I formally get into question A. So for question A, I follow up with the second step, which is the initial and final position. So the initial and final position, it's based on the question, as I mentioned just now. So the question asks for the velocity of the car after 10 seconds. So it means by it's asking for the velocity of the car at this moment when it arrived at this position over here. Okay, so since this is the place we are interested in, and this is where it starts off, we can know quite clearly that this will be our initial for question A. This will be our final for question A. Okay, so this is the situation that we are facing right now, and we have determined the initial and final position. Okay, so the next thing is based on the initial and final position that we have determined, determine the SUVAT. So you have to determine the displacement, the initial velocity, the final velocity, acceleration, and time, which is SUVAT. We write down everything, no matter whether whether we know the value or not. We just write down everything, put equal. Okay, so once we have done that, we check each of the kinematics quantity. Let's start with the first one, the displacement. Displacement is the change of position, in this case from the initial position to the final position. So what is the change of position? That's 25 meter. Okay, we look at it based on the initial and final. So 25 meter. How about initial velocity? Initial velocity is the velocity at the initial position. So velocity at initial position is just 0 meter per second. So this is 0 meter per second. Final velocity is the velocity at the final position, which we are interested to know, but we still don't know yet for now. So leave it blank. Acceleration. Acceleration, it's the acceleration that is taken throughout this whole journey here. We have a constant acceleration, but we don't know the exact value. So we leave it blank as well. Then lastly, for time, it mentions here that this journey here has a duration of 10 seconds. So that's what you write in for time. Okay, so once you have determined everything that you know and you determine everything that you don't know, you move on to the fourth step. And the fourth step is to determine the appropriate equation. Fourth step will be to determine the appropriate equation. So what is the equation to use here? How do we determine? First, we look at what we want to find. What we want to find or what we want to determine here is the velocity. After 10 seconds means by we are finding the final velocity. So our equation must have the things that we want to find. Next thing, what else do we know? Okay, just now is what we want to determine. Now is what do we have? What do we already know? So what we have known is the displacement, the initial velocity, and the time. So these are the things that we know. So we know that our equations, the best equation to pick should have your displacement inside, should have your initial velocity inside, should have your final velocity inside, and should have your time inside, because it contains the symbols that we have the value, and it contains the symbol of the things that we want to determine. So that would be the best equation to pick. So which equation consists of S, U, V, and T inside? Well, this one, no, this one doesn't have S. S, U, V, oh, this one don't have S, U, V, and T. Well, this one has S, U, V, and T. What equation is this? S equals to half U plus V, T. So this is the equation that we are going to apply here. So let's write it down. So S is equals to half U plus V, T. So once we have determined the equation, the last step will be to just substitute and get answer. Okay, I'm going to straight away write it, substitute it in this equation here. So we substitute based on the table that we have written here. We just put in the value that we have jotted down here. Okay, so if you see S is 25.0, this is half, U is 0, V is I don't know, so I put V, T is 10. So once you have written down everything, it's just substitution, and you should get an answer which is V equals to 5.0 meter per second. Okay, and that's it. Okay, you end up your answer with the magnitude and the unit. That's fine, okay? Because in here, right, technically you should include the direction, but velocity direction, in this case, they didn't even mention which direction is the car moving. So if they didn't mention the direction clearly, then it's not your job to give their direction back for the answer. Okay, so you keep it like that, that's fine enough. Okay, so now if we move on to B, should we start from step 1? Start back from step 1? Not really. If the situation is still the same situation, we don't need to re-visualize the same situation. We just need to start from step 2, which is the initial and final position. So let's try and determine it. For question B, your step 2 is initial and final again. So it mentions that it asks for acceleration. So acceleration at which specific moment? Well, there's only one portion of the journey, and it says it's a constant acceleration. So technically it means by the acceleration that is happening throughout this whole journey over here. So if it's the acceleration happening throughout this whole journey, we can assume that it's the same initial and final position, because our journey is now sandwiched between this initial and final position. So yeah, we still remain the same initial and final position. Let me write it down. So the initial for B is also here. The initial for B is over here as well. So nothing has changed. So if the initial and final position is still at the same position, we can reuse the SUVAT from the previous sub question. So means that we can reuse the value over here. So let's do that. S U V A T. So you write down everything. S U V A T. And since we are copying back the previous table, let's put it down, all the values that we know. 25 meter, 0 meter per second, and 10.0 second. The velocity we have obtained from a previous sub-question, so we can bring it over here. So this will be 5.0 meter per second. And now we are asked to find acceleration. So finish with step 3, go to step 4, we find the appropriate equation to use. Which equation is appropriate? You want to determine A, and we have S, U, V, and T information available. In that case, you can pick any equation that you like as long as acceleration is in the equation. Means by I can pick the first equation, the second equation, the third equation I cannot pick, but the fourth equation I can pick. Any equation that has acceleration, I can pick it because that's the thing that I want to find. But if you ask me which equation will be more suitable for an exam setting, I personally think if you have the choice to choose between different equations, use the information that is given in the question instead of use the answer from previous sub-question. So what am I trying to say is, if it's possible, maybe we can avoid using value that we determined from previous sub-question. Why? Just in case you got the previous sub-question wrong, if you choose to not use the answer from a previous sub-question, then your answer for this sub-question will be correct because you don't use mistakes from the previous sub-question. So if there's a choice, if you are given, if you are free to select between different equations, try to use the equations that allow us to not use answers from previous sub-question. Okay, so in this case, I'll use S, U, A, and T. So which one has S, U, A, and T? S, U, A, and T. So the equation that we will use is S equals to UT plus half AT squared. So my equation will be S equals to UT plus half AT squared. And now fifth step is just substitute and get answer. Okay, so let's do it. So this is 25 meter equals to U is 0, so you can put whole thing here as 0 plus half our acceleration, need to find it, and our time is 10.0 second squared. So if you move around, do your calculator stuff, then you get your acceleration is equals to 0.5 meter per second square. Okay, again, not a must. In this case, you cannot determine a direction, so you just stop here, then it's fine. Okay, so that's how you solve question A and question B. Let's move on to question C. But since I'm a bit out of space, let me push this to a new page. Now, for question 3, they ask for the displacement in the next 10 seconds if the car continues its motion with the same acceleration. Okay, they ask for displacement, but for the next 10 seconds. So is it the same as this 10 seconds? No, it's the next 10 seconds if the car continues its motion with the same acceleration. So what should you think? What should we imagine? How should we visualize the situation? We expect that this car will continue to move further for another 10 seconds. And the displacement is what you need to find. You don't know the displacement, but you know you end up somewhere there, and your acceleration is still the same acceleration as just now. Okay, so this is like an extended question right now. So let's try to see whether it still has the same initial and final position as A and B or not. So now we are going to solve question C. Again, we start with the initial and final position. So if you look at the initial final position, they ask for the displacement in the next 10 seconds. So means by their focus is on this portion of the journey, no longer this portion of the journey. So now where is the initial position? Where is the final position? Well, for this next 10 seconds, this 10 seconds here starts from here and ends at here, right? So our initial will be here, our final will be here. So it's different from question A and B. Your initial will be here, your final will be here. So let's jot it down. Our initial for C will be here, and our final for C will be here. So now this is a totally different initial and final position from A and B. So what does that tell you? You need to recreate your SUVAT. Okay, so for your step 3, which is on SUVAT, you have to recreate your table. So we are not going to refer to the table on the left right now, and we are going to determine a new set of SUVAT. So the S here, I'm not sure how much distance is this, and that's the thing that I want to find here. So I leave it blank. For the initial velocity, what is the velocity at this point over here? Well, do we know it? Yes, actually we know it. Because the initial velocity, or the velocity at this position over here, is the velocity of the final position that we did in A and B. So the final velocity that we have here is the velocity that this car has at this position. And now since this car here is this position here is our initial position, our initial velocity will be the same as the final velocity of the previous question. Because you see the final for A and B is the same position as the initial for C. So the final velocity for A and B is the same as the initial velocity for C. Okay, so let's write it down. This will be 5.0 meter per second. Then the velocity, final velocity, the velocity at this position over here, well, that's something that we don't know, so we leave it blank. For acceleration, they say it's the same acceleration. So this is the acceleration. We are going to continue this acceleration. So let's write it down, 0.5 meter per second squared. And how much time is in between this journey from initial to final position? Well, it's being stated here, it's 10 seconds. So do you see I attach symbol to all my values during the process where I write this table. I do not attach my T here, I do not attach my S here. Because the S can change with time, the S can change for a different question, the T can be different for a different question. So I don't attach my symbol up here in the diagram. Okay, so this is 10.0 second. So once we have filled in the table, we determine our equation. Okay, what is our equation that we are going to use? We need to find displacement. So we want S in our equation, and we are given U, A, T. We don't know about V, so we ignore V. So we want to determine S, and we have U, A, T. So which equation will be suitable? Let's try to determine S, U, A, and T. S, U, A, and T. So this is the equation that we're going to use. Same equation as just now. So let me write it down. We'll be using S equals to UT plus half AT squared. But at this point, if we choose to be conscious, right, because this is a new scenario right now, this is different from scenario in A and B. So maybe we can add on prime over here to make everything different from the previous value. Let's say the S in the previous situation is 25, then probably S prime will be a different value. So it's better that we put a prime to show that this is a different situation from A and B. You can do something like this. Okay, so once you have done that, again, substitution. S is something you want to find. U prime is 5.0. Time is 10 seconds. Plus half. The acceleration is 0.5. And the time is 10 seconds. Square. Okay, so we have submitted everything. Now if you calculate the answer that you should get will be 75.0 meter. Okay, that's how you find the displacement in the next 10 seconds if the car continues its motion with the same acceleration. Or in other words, the distance from the initial to final over here is 75.0 meter. Okay, so that's how we analyze a question. We start with visualizing the situation. Then for each sub-question, we determine its initial and final position. Then after that, based on the initial and final position, we determine our SUVAT. And from knowing what we want to find, what we know, we determine what equation will be suitable, and only we start to substitute based on the table that we have prepared. So that's how you solve a problem related to uniformly accelerated motion.